guys. So today we're going to take the circuit from last time and we're going to create the necessary files for manufacturing. We have a lot to cover, so let's just get started. So in the previous video, we explored creativity and innovation by combining a few different circuits. We learned about the 555 timer, we learned about some attack release circuits, and we also learned about VCAs made from Vactrols. Today, I'm going to walk you through my process for turning an idea into something that can be manufactured professionally. I'm only going to cover the high-level steps. If you would like to see some more in-depth tutorials about any of the software that you see today, just leave a message in the comments. I will review them and I will consider, your input and feedback for future videos. Okay, so before we get started, I want to discuss a couple things. The first one is how we are going to supply power to our module. So the URET standard provides us with a negative 12 volts rail, ground, positive 12 volts rail. The standard itself actually also calls for a positive 5 volts rail. But you may or may not have that in your rail, especially if you created this yourself. The other thing to consider is that even though we have regulated 12 volts, which we're only going to be using today, 12 volts and ground, we should assume that the bus could still pick up noise. So we're going to add a 10 microfarad capacitor for some noise filtering. We'll also toss in a ferrite bead for some further filtering, and we'll add a diode, some fast switching diode for polarity protection. Something like a Schottky diode will probably be really, really good. The reason for it is because Schottky diodes have really fast recovery times and they have very low voltage drops. So we're gonna lose less voltage by putting this, since we have to put it in series. And the other thing is Schottky diodes also handle power dissipation much better. So they're really, really good for filtering like really quick transient peaks on the line. Okay, the other thing that we'll should consider is having at least some idea of what the module will look like. And the reason we want this is because, we're going to be laying components, and if we wait until the very last minute to find out what our module will look like, we may end up having to redo a lot of the work. So it really helps to spend a little bit of time and just at least have an idea of, what the module size should be, what the layout of the knobs should be, like, how many jacks are we going to put in there? Do we need LEDs? Do we need buttons? That sort of thing. So yeah. Okay, so next, let's move on and let's discuss the high-level PCB design process. All right, guys. So I have here sort of like my 12 steps for this build. We are going to start by recreating the schematic in Eeschema. And while we're doing this, we're going to make sure that every component that we place has a footprint associated with it. We are going to make sure we have reference names for all of those components. And we're going to make sure that we're running the rule check routinely, right? So, and often, frequently and often, just to try and minimize the amount of troubleshooting that we have to do. Once we have everything in place, we're going to take a little break and we're going to switch over to a design software just so that we can create an outline of what our front panel will look like. This will help us in placing our components on the boards. So what we'll do is we'll create that, we'll export it as a SVG file, and then we'll import it into PCB New in one of the user layers so that we can easily just trace that and create our edge cuts with it, okay? And once we have that, we'll import all of the components from the schematic and we'll start placing them. We'll place all of the components on the boards, and only after we have placed all the components, then we'll create some copper fills and we will trace all of our electrical connections on the board. Once we've completed with all of that, and then, of course, we're going to keep, be running the electrical rules check there as well, because we can run into problems and it's easier if we find them sooner rather than later. So when we get to near completion, since we're making a multi-board synth here, right, or module here, I will walk you through sort of what I do to create this, and the outcome of that will be Gerber files for each board, right? So since we're likely going to split it into two boards, a control board and a main board, and then a panel, we'll have 3 sets of files. And then lastly, we'll go ahead and order those from our manufacturer, which, by the way, PCBWay is sponsoring this video today. And so I wanted to take a quick pause and just say thank you so much, PCBWay, for sponsoring this video. And a special thanks to my friend Luz over there. Thank you for making this happen. Right, so let's get going. I'm going to sort of be quiet now and let the whole process play out. I'll speed it up and then I'll slow it down and talk about a few things here and there. And then at the end, I'll walk you through the ordering process on the actual PCB side. Okay, so let's go ahead and open KiCad. By the way, KiCad is my preferred tool for doing this sort of thing for a few reasons. One of them, it is open source, although, you should consider donating because it is quite good, and it'll, it helps support or ensure the support of it in the future. So the other thing is KiCad is really feature rich. Out of all of the free options, KiCad probably has the most features available. And it has a tremendous community of people, and there's just so much information about it. It's fantastic. Okay, so first we are going to start with the schematic editor. Okay, so let me go ahead and I'm going to create a new file, to a new project. And you can save it just anywhere, right? But I am going to create a new folder for the project, and this is going to be called Punky's new Punky's new brew. Okay, so, and now the fun starts. Yeah, when you start KiCad, you're gonna get this really, quite intimidating view. I'm gonna speed this up, like I said, because there's just so much to go through. But if you're interested in learning more about KiCad, do leave a message in the comment, and I will be more than happy to create a video for you guys where I can go over all of the things that you see on the screen here. Okay. So, actually, this is a good opportunity to show you something. Um, so in KiCad, we have this symbol editor. One of the things, let me make this a little bit smaller. So here we go. Let's put it right about there. Okay, so you can create your own library. These are libraries that you that you import or whatever. But when you create your library, it's a lot easier to find what you want. So if you have something that you use all the time, then what you can do, say for example, we have that capacitor that I was looking at, right? So let's look at in here, C_polarized. And if you just hit E, you can assign a footprint. And I know that the footprint that I like right here. So the footprint that I like is this capacitor, this one right here, which if you can, click it, you can also filter, go through the window here and select it, right? So it's this guy, this particular one, right? So these are the ones that I have on hand. So, so once you have assigned this, then what I can do, actually, say in here, okay? So notice that there's a little star in here. It says like it hasn't been saved. So before, what I'll do here then is I'll do a save as, and this will let me assign my library, right? So once I assign it to my library, then I can easily use it, right? So now I can save these guys right here, right? Save, and then this guy I'm gonna discard, okay? So when I come back then over here, what I can do is instead of using this guy, I can add the one from my library. So C polarize, and already has a footprint associated with it. And so I guess maybe a good time to pause and talk about a couple of things here. The first thing is this diode right here is for polarity protection. The ferrite bead is for some noise filtering. This will filter out high frequency noises. And then same thing with the capacitor that's over here. This will just make sure that the if the module requires a lot of power, that it's readily available. So it's like holding a reserve for it. And what this does is it smooths out the line and also filters out some unnecessary noise, okay? This is gonna be our power, right? So now what we can do is we can also add ground. And this right here is gonna be our ground. Keep this tidy. And we will also add a 12 volts. Just this one there. On a rules check. Now there are two errors. So these errors, it says that they're not, we have this power object here, but we haven't actually told it that it's a power. So this is really easy to fix. All we have to do is just put an additional component in here, which is invisible, and it's called the power flag. So we will add it anywhere, but right here is good. And then we also need to do the same thing with, in fact, let's rotate this. There we go. With the ground one right here. So this right here, we're going to duplicate it. I'm just going to put it right there. So now if we run our rules check again, we see there's still one. Oh, that's because this needs to be right here. There we go. No error. So again, this is why it's useful to do this as you're doing it, because later on, if all you're going to see is a whole bunch of red errors in there, and it's going to be very difficult. Okay, so let's close that. Put this aside. We have our power. This is all we need for our power. Okay, so at this point is kind of decision-making time. So this is pretty much the schematic here as we had it before. I started adding the jacks, but I am quickly realizing that I'd like to make some modifications so that certain signals are normaled when there is nothing connected to the jack, and then it behaves in a different way when connected to the jack. The other thing is I'm really considering putting a switch, but I want to know whether or not it's gonna fit. So I think before I finish this schematic here, I'm gonna move over to my design software, and I'm going to start working on the layout for this. And so here what we have is Inkscape. And as I mentioned before, or maybe I didn't, but this is Inkscape, and the buggy itself, it runs really terrible on my Mac. So I'm not gonna use it for very much more than just to get a general idea of what I'm going to be doing. So typically, first thing I do is I have already the Synth Panel Creator plugin, Synth Panel Designer right here. And so when you bring this up, it gives you this sort of interface here, which I'm gonna kind of put here to the side so you can see over here what's happening, because you can actually do a live preview of this. All right, so I am going to choose panel, and for what I intend to do, I'm gonna say live preview. So here's my live preview. I think I'm gonna try to fit everything into 8 HP first. And I gotta pause this because my phone is ringing, so excuse me, guys. I think I'm gonna try to squeeze everything into 8 HP. I have a couple of modules that are that size, and I think it would be good to keep some consistency, especially how I'm gonna be using it with my with this GIF that I have. And given that my case is a little bit deep, I'm gonna make use of multiple boards. So here we go. I'm gonna make it 8 HP. Okay, and then the key thing here is that this is going to just be the template for the faceplate. I still will need to figure out how far the inner boards are, but we can do that in KiCad. This primarily is just to give us the panel size. So I could also use this software to just kind of get an idea of whether or not things will fit. So let's do that. Let's do that real quick. I'm going to fast forward this and then we'll come back and I'll show you the actual file that I'm going to import over to the other side. Okay, so here's what I'm thinking we can do. So since we have 7 knobs, right? That means that we could have that trigger right here, and maybe an LED. If we choose to put even more LEDs, we can probably put them in between these guys right here. And so 8 inputs. So this would be the output. Right? This can be an output. This could be the trigger input. This could be the CV input 1, CV input 2. Then over here, we could allow an input for the VCA, right? So then that way we could use this as a VCA if we wanted. We could allow output of the envelope, each of the envelopes, 1, 2, right? And then we could also, I forget what this one is. Let's see. So we could do actually the inverted envelope output, right? So we could have an inverted out, the regular, and then the output of that second, just the release one. So yeah, this could give us a few more extra options for usability in here. So let's go with this and see how that pans out once we start getting things on the board itself. So I won't be able to export this because if I try to import this, it's just not gonna look terribly good. So I'm gonna save this. I'm gonna set this aside, and then I'm gonna create another one with just the panel. Okay. So yeah. Okay, so now we can take this file over to KiCad and just kind of see. Okay, so we're gonna continue on here. And so now that we have a better idea of the things that we're gonna add, now I can go back and finish this thing here because I only have 1, 2, 3, 4 of the jacks that I wanna be putting into this thing. So I need to put the other 4 in. And I already have the potentiometer, so that should be good there. And yeah. By the way, if you cannot find Shakti diodes over here, you can easily replace this with the one in 4148. They will have the 4148 are silicon diodes, and they have larger voltage drop. right? Like most diodes, it's like I think a 0.6 or 0.7 volts. And while the Schottky ones are usually around 3 volts, I think. No, sorry, 0.3 volts, I believe. Always, here's something, I mean, piece of wisdom. I am just starting out, like all of you guys. I don't have all the answers. I'm sharing with you guys my experiences. And I do not claim to be an expert at this. I'm not. I'm learning just like you are. So always take my word with the grain of salt and, you know, do some research, validate it, test it, right? So that's the important thing. Test it, try it out, okay? I don't have all the answers, and the answers I might give you might not even be the right answer. But yeah, always test it out. So these jacks, actually, hold on, let me mirror this. There we go. These jacks, the third pin is normaled. This is what it's meant by having a signal being normaled here in this context. What this means is that when there is nothing plugged into the jack, whatever is on this pin, it's making a connection to pin 2. Pin 2 is the tip of the cable, right? Of the cable socket. Sorry, jack. No, the cable pin. And so what happens is that when you input the cable into the jack this way, right, it pushes this pin away from it and thus breaks this connection, right? So when you push this in, then it receives the signal from what's coming out. But when you don't have anything in, it will take the signal directly from the APC. I hope that makes sense. This button right here allows you to do you know, footprints in batch. So this is, if you didn't do it at the beginning, this is how you would go in and fill all of them. As you can see, as long as they have the same value, they will be listed as in list. So if you were to change this one here, it will change it for all of the ones that it sees there. Okay, so let's do the LED. So for the LED, actually this is the dip package. So the LED, so we would go LED. We know this is through hole, and I know that it is a 3 millimeter, right? So this one right here will probably work. Right. So I'm gonna select that one for that. And then for these guys, these are dip 14 as we saw in the data sheet. Dip, package dip. And I want dip 14, and I'm gonna be using sockets. So I am going to select this one. Yeah, and then I'm just gonna copy that to that. And now, run a rules check, everything's still good. Close, and so the next piece, let's make sure that everything has reference values. So we're just gonna say annotate, annotation complete, close. We changed something, so you know, run the root check again, close. All right, so now we can move over to the sheet, the other side, yeah, to PCB new. So the easiest way to transfer everything that you see here on the screen is to just hit this button right here, right? So we're gonna open in PCB Editor. So this brings the PCB new, right? Right now we have nothing. So before I place anything in here, at this point, this is where I'm going to select one of my user layers right here, like say Maybe user 7. I find that this kind of blue might be a little bit easier to see, so let's do that. And then I usually go into import graphics, right? And again, so right now it's set to user 9, layer 9. So, okay, well, I guess I'll leave it there. And then you can just, browse. So actually, before I import that one, let me show you what the default export looks like. Right. So you see it's all blocked off. You can't see anything. So that's a problem, right? This is why I removed the color on the other one and I made those lines thick. So let's try it again. This time I'm gonna pick that one. Okay, so this is gonna allow me to create the edge cuts for the front panel. But we still need to figure out where over here we're gonna put our circuit board, and it needs to be just a little tiny, just a hair smaller, just so that there's enough wiggle room, and so that you don't when you sandwich the different layers together, that you can ensure that the boards are going to be inside of the width of the module itself. So this is a time where I would probably take my calipers out and then just measure from the edge of the physical device of where this is going to go to where the opening is. So like what the rail width is, and I would subtract this from here, and then I would give myself a little extra room, and then go from there. And so these are our panels. Right now they have nothing. They have no components. So if we go and look at the boards, there are panels right there, right? But there's nothing on them just now. Okay. All right. So now we're gonna import all of the components. I'm gonna relink everything. Blah blah blah. Yeah. Okay. And so close this, and now we have the ability to place them. So I usually just kind of place them out somewhere. And then the fun starts, right? Because we got to start laying everything out. One thing that is good to do here is if you make some room, then what happens is that whenever we select something in here, it'll go to the one that you're editing over here. So this is a really good way to reference what you want, especially if you use the automatic namings, which is going to give you like, these names instead of like naming it something like, CV1 or like audio volume or whatever that is, right? So I think I want to reverse this. I think I might want to put the 4 knobs on this side and the 3 knobs on this side, just so that I can group the outputs a little bit more like logically. And then our connectors, the connectors for the 2 boards will go on the edges here. So we'll just make sure that there's enough room. Maybe we'll put one here. And then maybe we can put another one right here. Like that, here. And then maybe one more on this side. Just to keep it sandwiched together. That way we know that it'll stay nice and tight. It is a really good idea to put your bypass capacitors as close to the pins of the chips that it's supplying that reserve power for, This will help make sure that you don't starve your chip. So if it requires more power, then it can easily just get it from the bypass capacitor. Okay, so now that we have the things kind of somewhat arranged, we know that exactly what room we have, we can kind of rearrange things so that we have a little more room to play with when we start laying down the tracks. And but before we do that, I still haven't added the connectors that we're going to put going between the boards. So what I'm gonna do next is I'm gonna figure out exactly how many I want to put. I'm gonna put more pins that I need to connect the two, and the reason for it is because I want the pins, the headers, to give me more stability between the boards. And then that way I'll be able to throw or attach more pins to the ground fill, right, between the two boards, which will help me in a couple of ways. One, it will help keep the noise, and then make sure that I have a really solid connection to ground in there. Okay, so now we are ready to do some ground fills. This will need it too, but we're gonna wait until we're actually doing the front panel. I'm gonna leave that for last. Okay, so I'm back in front of the computer, and we'll see if we can wrap this up today. We are gonna finish tracing all the electrical connections, and then we get to my favorite part, which is designing the front panel. Okay, so I just realized that I've been editing for probably a good hour, and my recording software was frozen. So let me walk through what I've done. So yesterday we left it with the ground fills added, I believe. But so I've added the ground fills. I switched around some of the ports just to make it more convenient on the control board, and I started routing the tracks. Okay, so what I've done is I've configured a few track widths right here, so I can select the track width in here easily. You can also use it with a net class. If you choose, you would just configure your net classes over here. Okay, so I'm just using the predefined ones. I finished routing the control board, and as you can see, it's on both sides. A few things to talk about here is, I tried to keep my tracks relatively tight. So this makes it a little bit easier when I have to cross them. Like if I used to have to use a via to go into the other layer, it makes it a little bit easier, especially since I'm not arranging the board for optimal track, but rather for more ergonomics, right? Because this is a board that's it's going to be dependent on how you intend to use it. Over here, there's very few components, so I just didn't really bother too much. But in hindsight, I probably could have done a little bit better job because, as you can see, a lot of the nets are fairly intertwined here. And so I'm going to have to deal with that. All right, so we're going to run our first rule check. We should ideally only see errors for these two unconnected tracks right here. Hopefully, we'll see. Ooh, that's a lot. But this is because I think a lot of these have to do with my comments. So let's remove those comments. We don't really need them anymore. Okay. All right. So now these is okay. That is okay. That's okay, and that's okay. Here comes the fun part. So what we're gonna do, just to make sure we get all the sizes right, I'm gonna focus on this here, on this right here. And I'm gonna use the markings over here to tell me where I need to put the holes on this side. But before I do that, so what I'll do is I'll select one of these user layers to trace things. I think it'll be the easiest way to do this. This is the way I've done it for all of my builds so far, and it seems to be working all right. So we'll stick to it. All right, so we need to specify where the order number is going to go, so it doesn't end up in the front of this. So I am going to I'm going to put it on the back side of this. Okay, I think I'm quite happy with this, so we're going to leave it as is, and now we're going to move to creating the Gerber files. Okay, so this is the board. I mean, this is the file that has already been created and is finished. And so what I'm going to do is, from now on, if I need to make any edits or changes, we're going to use this file. But to generate the Gerber files, what we'll do is we'll create copies for each board, and then we'll delete the pieces that don't fit there. All right, so as you can see, I've deleted this is the front panel, and I've deleted the other boards from it. So now if I run the rules check, I should have no problems. Well, actually, I am going to have some warnings, but that's okay. Warnings are okay, you know, pretty much safe to ignore as long as it's a warning, but errors, you definitely do not want to have any errors. Okay, so I'm going to go ahead and do it. So when we are exporting files, what we're going to do is, it's not intuitive. It's not print, but plot. We're going to plot, okay? And so this is going to come up here, and we're going to select the layers that we want included. Okay, so this looks correct. These are all the layers are used. I don't want any of the user layers. Okay, and this is probably good, everything we need here. Okay, so then to generate this, we hit plot. Before we do that though, we should specify the directory in which we're going to export the files. So if we don't do this, then it's just going to put it in the folder where your project files are, and then it's going to get all messy. So to make it easier for ourselves, especially since we have to create an archive, a zip file to upload it, we're going to choose a directory. And now that we have the directory set up, we can just say plot. Okay, and the other thing that we're going to do is we're also going to generate the drill hole files. So we just go here, and these are the settings that I have set up in mine. Okay, so it's done, so now we close it. And then what we do is we repeat the process for the other two. So there are 3 sets of files. So the next thing we need to do is we need to look at the Gerber files with a Gerber viewer. And I like to do this on the site where I'm going to be ordering my boards from. That way, you know, if it looks good to me there, it's going to look good to them as well. Okay, so here I have the website. So let's see if we can figure it out. This is actually my first time doing this as well. So it should be a learning experience for all of us. Okay, so I'm gonna go to instant quote. Here we go, quick order. Okay, and here we can look at the online Gerber viewer. Cool. This is awesome. What we're checking for here is just to make sure that that nothing looks out of place. So this obviously is the front panel, so there's not much to worry about. This is where there is going to be nothing, right? Like that's that keep out area. So it should just be the plain fiberglass, right? Which should be translucent, especially since we said to keep out any copper out of that area. Okay. So, so we're going to do 2 layers, FR4. The defaults here are fine for what we want. Keep note that if you change any of these defaults, you might incur an additional cost. So this should hopefully have it relatively inexpensive. Let's see. I'm going to use the hassle with lead just to keep cost low. This will give it a nice, for all the pieces that we did on the solder mask, it'll keep it like a silver shiny color. It should look pretty nice. Yeah, for this one, since we specified a location, we're going to specify location. Okay, and so that is it. So now we can hit calculate and save to cart. There we have it. All right, so once we have this, then we should be able to just proceed to checkout. So I'm going to skip this piece for now. Unless there's something that I need to share with you guys, but otherwise I think we should be good. It's just going to go checkout. You're going to fill in your shipping address, your billing details, and then you're going to wait, for your boards. Depending on the shipping that you select, you might get it, in a few days or a few weeks, right? So, yeah, all right, okay. Okay. So we've come to the end, and what a journey this has been. I know that we sped through a lot. There's probably so many questions you guys have, but let's just do a quick recap here. So we talked about the steps required for transforming a breadboard experiment into a professionally manufactured device. We covered the PCB design and layout considerations. I took you through the process of importing or recreating the schematic in Eeschema, and then later on transitioning to PCB new. We also talked about the Gerber file preparation. And then I showed you a quick little demo of how easy it is to get those files submitted for production. And yeah, it is that easy. Of course, the hard part is getting all those files ready, right? And as you guys saw, I spent like 3 days making those the files for this project. Anyway, yeah, if there's anything that still remains unclear, leave some comments, and I'll try to get to them. And yeah, if you have any ideas for the lab or future videos, leave some comments as well. Also, manufacturers often provide really great support, especially for beginners. So at least it has been my experience so far. And even with PCB Way, yeah, this was my first time working with them, and the experience was fantastic. So I'll definitely be using them again. And yeah, thank you, Luz, for making this happen. And thank you to everybody for sticking with me until the end. Look, I started making these videos because I find that explaining things to others really helps me solidify my own understanding of these topics. I am learning this stuff just like many of you guys are. And I really hope that these videos are help for you in your journey. So yeah, look, knowledge is for sharing, right? And I am committed to sharing my experiences with you guys. So, okay, all of these supporting files are going to be available in my GitHub page. I'll put all the Gerber files in there, and then just check out the links in the description, also in my blog post. And if you enjoyed this video today, please hit that like button. And if you want to know of more content when I have it ready and available for you guys, make sure to subscribe. Tell all your friends about it. And yeah, I'll see you next time. Remember, stay creative, help and support each other, and we will do great things. Okay.